Yeah. We are back after a break, and I am Abhijit. I'll talk about what are the best practices about. I'll talk about chef in general and what are the best practices to write recipes and how we can write better recipes so that we have more reliable infra. People will be confused. What is chef? A lot of people might not know what chef is. I mean, I guess a lot of people here would know what chef is, but people watching online would be confused that have I come to the wrong meetup? Did I lost my way on the way? I mean, did I come to the wrong cooking meetup or something like that? But yeah, chef, we're going to talk about Ruby. We're going to talk about chef, infrastructure, systems, and all. So yeah. A bit about myself. I am working at Gojek and I'm working on fabricating and establishing the DBaaS platforms. So we manage and extend our platforms for onboarding Postgres, Patroni clusters, Redis, Consul, and other databases, which can be used by developers. And yeah, I'm here, so I'm a Ruby enthusiast, definitely. And along with that, I work with infra, so I work with DevOps as well. When I'm not coding, you would find me lifting at my gym. I have a gym at my home, and I'm a musician, so I just play music, compose music. Yeah, so I'll set up the agenda. We'll talk about what actually Chef is, a bit about how it works, so that we can truly understand how and what are the best practices to write things and write configurations. And this would not be only specific to Chef. This can be applied to any configuration management language like Ansible, Puppet, Salt, or whatever is required. And we will go through a few production scenarios, see how it works in production, and a lot of scenarios where your bad practices can lead to bad incidents or production incidents, and how it can be solved with good practices, and a few guiding principles on how to write better configurations as such, and a few comments on what Chef and other configuration languages or configuration management libraries are going forward. Yeah, so what is Chef? It is a configuration management tool. So what is configuration management? I talk about it as well for people who don't know. And a lot of folks in the cloud ecosystem are going towards infrastructure as code. If you're a small startup, you don't really care about infrastructure as for now. But when you start hitting the scale, you would need to care about, because there's 1,000 VMs running here. You don't know how to provision them. You're provisioning them manually. You're configuring them manually. You are trying to run things on them manually, and that's a bit difficult, right? So it solves the configuration part of the IAC ecosystem, which is more importantly the provisioning part, which is handled by Terraform and CloudFormation and other stuff. And then the configuration part is handled by configuration management systems like Chef, Ansible, Puppet, etc. And it helps you also to automate the deployment and server management, because like, let's say there are hundreds of deployments happening every day, and you cannot really go ahead and perform deployments manually because it's a lot of infra, and like for bigger organizations like Gojek, you cannot have granular access to application folks as well. I mean, application folks would not agree with this, because a lot of people came from earlier background of Gojek who were like, we won't have access, and we don't want to relinquish our access to the other infra folks, but we need to automate this so that people can actually focus on what's required for application developers, which is application code, right? We take away the pain from the application owners. So it helps in automation of deployments and server management, and then it's mostly used in VM workloads, so it's also somehow used in Kubernetes cluster or on-prem devices as well, but not a lot. Mostly the context of this talk will be around virtual machines. Yeah, so what does configuration management even mean? Why do we even need it? What's the point of all it? So the point is that there are multiple VMs which are running in multiple environments and which are required to have multiple different configuration. Let's say there's a Rails server running, and you need to set up Rails on all of these VMs. A new application comes in and they want to have configuration for Rails, Nginx, Grafana agent, Telegraph, Fluent agent, whatever. There can be multiple components of, we'll talk about that later as well, but there can be multiple components of applications and agents running on a VM, which needs to be set up and which needs to be in a proper space and maintainable so that the desired state or the consistencies remains across all the systems. Yeah, and apart from that, the policy and standards also really required, because you would hear from a lot of security folks talking about that we need to harden our VMs, and we need to talk about doing this CIS hardening. A lot of people in security would know about it. So what they do is that they write a cookbook, they run that cookbook in all the VMs so that it is hardened according to the CIS principles, according to the security principles, and security team does that. Similarly, what other teams does that they want to move from Telegraph to Grafana agent, let's say. There's a new ADR, and people want to move from this tooling to that tooling. How would you do it? On, let's say, 5,000 VMs. That's a bit difficult, right? So that's how it is being done via the configuration management systems. And yeah, has been a recent study which tells you that around 80% of outages on VM-based workloads are being caused by misconfigurations. Let's say I went into a Rails VM, and then what I did, I just changed the manual configuration of the Rails, and the whole system went down. And let's say I would just go into the Rails recipe and just push the bug. Multiple VMs will start coming down if you don't have proper standards. So we'll talk about that as well. Just talking about configuration management, why do we need it? It's just an easy thing for system administration or DevOps, which we call now, because DevOps platform engineering is now all cooked up into one big umbrella, which all was system administration earlier. So we'll talk about it, that how we talked about earlier, that how multiple VMs can be managed via configuration management, and then you can eliminate the human error because you have clear, predictable configurations. You will have clear and predictable maintainable infra. You won't have any issues with that. So yeah, automated infra is equal to there is resilient infra, and you won't have any issues with that. And yeah, now we are working towards moving everything to the cloud. I'm not talking about the cloud native and container ecosystem, which we'll talk about later as well, but not right now. We're only focusing on the VM workloads. Yeah, the main question, why are we discussing about Chef in a Ruby meetup? The point is that Chef, the core framework of Chef has been written in Ruby, and the recipes which come around, we write the configurations, is written in Ruby as well. So the main core principles of the Ruby language are applied to writing Chef recipes as well. And all the principles of writing Ruby, like RSpec, writing TD code, writing integration tests, and all the other principles apply here as well, which is often missed by a lot of infra engineers, that they don't really write unit tests, right? So it's a norm in the infra world that we don't need unit tests. So yeah. Just a comment on how Chef works, because we'll delve deep into what can be the good practices and what can be used to make it more efficient and more predictable. So just a comment on how it works. Yeah, it's just a image I just stole from the Chef website. It just tells you that Chef has a server, the main server in which all the cookbooks, and cookbooks, I'll explain what cookbooks, recipes, and all that resources that means. The main recipe is a fundamental configuration element. If you want to install Nginx on a server, you will have a recipe for that. And recipe will contain resources for doing proper singular actions, like creating a file, like creating an Nginx configuration file or something like that. So it will have multiple steps of resources in a single recipe. So all these are stored in the Chef server, and there are multiple Chef nodes. Those Chef nodes are they can be Kubernetes clusters, they can be no VMs, they can be on-prem devices, they can be network devices. Those are all considered as Chef nodes, so that Chef client runs on all of them and maintains the configurations and makes it consistent. Yeah, let's talk about how the configuration is actually managed on a Chef server. You would think of the Chef node as a VM. Let's talk about it as a VM. And you would have a run list as a singular stream of configurations. Let's say we have Vault, Grafana, and Rails we want to run on a VM, right? We would first start by setting up running the Vault recipe, which would set up the key, register it to Vault, something like that, start the Vault agent, then start the Grafana agent for monitoring, and then start the Rails recipe for setting up Rails, everything. The attributes of the chef node define the configuration of the recipes which are supposed to be run. So the point is that if I want to tell that I want X version of Rails, it would be defined by the attributes of that chef node. And those attributes are defined by the deployments which are coming through. So that is the interface through which the Rails or Grafana agent or Vault recipe interact with the chef node and perform customizable infra. So that's what is the interface through which developers and infra people interact with code. Yeah. So let's talk about an application system, a production application system in which Shivam talked about, let's say, a similar system like this. There's an API traffic coming via load balancer and then Rails server VMs. Let's say there are 3 VMs, and then we are talking to Patroni, which is the flavor of Postgres, is just a high available flavor of Postgres in which it's talking to the master, and it is replicating to the replica, and yeah, just a very basic system. But there might be multiple systems like this, like let's say 100 systems like this, 100 microservices, because in the microservice architecture, we can have each VM would have each microservice would have its own database, own Redis, own Elasticsearch and everything. So it can be replicated into at least 10 to 100 scale, definitely. Let's talk about what happens inside a VM. Keep taking the Patroni VM as an example. What happens is that there's a Patroni process working, there's a console agent working for doing service discovery, there are exporters, multiple exporters running for exporting the metrics and converting into, let's say, Prometheus style metrics and putting it to Grafana agent. And there's a logging Fluentd agent which is talking to Patroni, which is the application. That Patroni or Postgres can be replaced by any Rails application as well. So it's just a common example. This is how most of the VM processes are there, and they're mostly managed by systemd or any other process manager in any VM or so. Just a comment on how the recipe would look like for Patroni and what could go wrong. So let's say this was the recipe of Patroni to set up the Patroni configuration, and we define the Patroni host as a node IP address. We pass the IP address through which it is being used by the REST API host. What happens in the REST API host is that this is being configured in Patroni to talk in between the nodes. So if you see here, these Patroni VMs are talking to each other via that Patroni host. And that is required to maintain the redundancy of the replication, which is already present. If I go ahead and change that REST API, something bad would happen and the redundancy would stop, the replication would stop, which is not a good thing for production databases. And let's say we have no test written because we don't write tests. That's a bad idea. Someone comes in and let's say they're testing something and they just change the Patroni host from IP address to host name. And then what would happen is that they pushed all these changes without testing in the local environment. So what would happen in the local environment? It might be possible that the host name resolution is not working. For many of the new environments in GCP, the host name resolution doesn't work if you don't ask it specifically. And let's say we have multiple environments running and we are managing the cookbook for multiple environments. It would be a possibility that it won't work in one of the environments. Yeah, when you test it for one environment, it would work. When you scale it to another environment, it would start failing like this, and the replication will stop, which will leave your application in a very unstable state. So yeah, here comes the core principle of TDD. If you would have written the test, you would have caught it much earlier. You would have written this test starting with that, this should be an IP address. This is the expectation I am setting, that it is the IP address. If the first engineer had written the code of writing the tests and then refactored the code again and again by the cycle, which everyone knows here, I am sure about it. You would have, if the engineer would have written this code like something like this and checked the configuration in this format, checking the configuration file which is created out of it, and check if it's a valid IP or something like that, or a valid host name, it would have been caught much earlier, and they would have refactored the code in a way so that the host name is now supported. So that would have been, that catastrophe would have been stopped by just writing tests, which is very basic, which everyone follows. I agree, in the application space, not in the infra space. A lot of people don't follow that, which I have seen in multiple actual cookbooks, and this is an actual issue. We face this. So most of the issues which I'm showing here is that actually we faced it in actual multiple databases. So again, let's talk about another scenario. Is that there's a way in which you can do failover in Patroni, similar to an highly available application system. Let's say if your master goes down and there are multiple replicas, what we do to save cost is that we make one of the replicas smaller and make one of the replicas bigger, because we want to do failover only to the bigger replicas, and we can define it via a failover tag, and Patroni would know that it needs to do a failover to a bigger VM, and we need to implement this architecture somehow. And people mostly miss integration tests in this space. They would not write integration tests. A simple integration test would have solved this. Like if you go ahead and not write integration tests and push it to production, or even integration, what would happen that the replica or the failover would happen with a smaller replica, and the smaller replica would start getting overburdened, and that's not a good idea, because your application will stop. As Shivam was saying, your application, the DB is gonna get smaller, it's gonna get less load, or more load. It won't be able to handle it, and the application will choke out. So this is also we have faced. This has happened a bit, and it continues to happen. So just a small test like this would have told you that this is going to work the way you intend to, because most of the tests we perform on infrastructure is to create actual infrastructure, and you would not have found it via that way. So these were the basics, TDD and writing integration tests, which a lot of people miss. But yeah, I will add a few comments about the loading process, how Chef loads. And yeah, so Chef, whenever you run this run list of recipes, Chef does 4 things. First of all, it loads all the resources, all the recipes from the Chef server. It asks what are the recipes I am required to run. It fetches all the recipes. And then in the next step, which starts the execution, in the compile phase, it builds the resource collection of all the resources which are required to be run. Resources is just a singular action of a recipe. Let's say in an Nginx recipe, I want to create a file. In a Vault recipe, I want to generate a key or register to Vault or just anything. So those are being handled by the resources. And during the converge phase, it would run these resources one by one and perform actual change on the node, like creating files, creating directories, changing files. And these are being managed by the attributes and stuff. This is how the Chef execution works behind the scenes. So what would happen if you write code like this? If file exists foo, execute this. What would happen is that the bad code would run during the compile phase, and it would check if this file exists even if the above code has not run. So if the above code has not run, it will try to check if the file exists. It won't find it because it's not there, because the converge has not run. Remember, converge runs, and converge only performs change on the VM. So that won't happen, and that will bring the VM in an inconsistent state and not in the desired state what you actually mean. So it can be just solved by writing an if guard, like just write only if, and this would be considered in the actual execution and the converge phase, that if does it file actually exist during running the VM. So yeah, let's talk a bit about convergence. It's sort of getting a bit technical, but yeah, we need to know what actually means before going into the scenarios. I'm just trying to set up the plot here. Idempotence we know because we have worked with REST APIs, and it just means that you need to, whatever you perform, a function of x, function of x equal to function of x. So whatever you perform multiple times on multiple action should not have a side effect, should have the same effect. So, and if a resource is idempotent in the chef world, it will not get added to the resource collection. So this resource collection you would have seen, right? It will not get added here if it is idempotent as such. And convergence is just bring the state in line. I'll just give more examples what actually idempotence or convergence means. So this is an example of an idempotent operation. If you just create a file, you run it multiple times, there would be no change in the actual output or actual action of this idempotent operation. You can just, the tree of that directory would be the same if I run it 10 times or 10,000 times. And the convergent operation in regards to what it will do is that if it has run once, it will ignore. It is a major principle in chef resources that you make sure that the resources are both idempotent and convergent. Most of the cases, at least 90% of the cases, you need to make sure that both are there so that your resource allocation is being done correctly and the resource collection created is as less as possible. So I'll explain why it's required as well. Yeah, it's just that idempotent means that I want to do as less as possible. If it has been done once, I don't want to go ahead and do it again. In the chef world, because idempotence can mean multiple things in multiple ways, but the actual gist of idempotence and convergence remains this in chef. So you can see, talking about resources, all these chef resources are idempotent by nature. But if you're going to write custom resources, you need to make sure that the resources are idempotent. But this resource is just idempotent. And if you want to make sure that if this file is being created in this directory, this is now convergent as well, because it would not run if it's not required. Yeah. But yeah, why do we need it? Because it's easier on the system. What happens in a deployment system is that whenever you deploy an app, the chef client runs to fetch the package and restart the Rails process or Patroni process or whatever it is. But the point is that how much time would you want it to run so that it performs the deployment process, right? It needs to be as less as possible so that if a resource is idempotent or is convergent, the resource collection would be as small as possible, and it would be very CPU efficient as well. And we would be the resources would be more predictable. We would have more predictable infra, maintainable infra, and yeah, just a case study on how is it easier to roll back. Let's say your team from the Grafana or the observability team has pushed change on monitoring agent somehow, and the monitoring agent stops working, right? The monitoring agent does not work in all these VMs, and you're not seeing anything on your Grafana. So this is a big issue because monitoring loss is a big loss. And but what they have done is that they have created a recipe which is meant for one-time use. If you see the not-if file, it will just say that I would not change this file if it is there, which is a bad idea because this resource is idempotent. If I went into this file and performed some change, if guard was not there and this resource would have run, it would have bring the file back to the state which is meant to do. So this is easier to perform rollbacks on because if a new version had come in and performed an invalid change, I can just roll back. And doing a rollback would make sure that all the Grafana agent are back into the consistent state which is meant to. Yeah. Talking about a few guiding principles at the end. You need to make sure that your configurations are written in data. It should be written in hashes. It shouldn't be that your configuration is being defined as manually defined in each of the nodes. It needs to be written in data as more as possible. I'll give an example as well. And you need to manage systems, not just records. So like let's say there are multiple applications like these, right? And imagine that this console agent setup is being done by each of these applications. There's one Rails recipe, there's one Patroni recipe, there's one Elasticsearch recipe, there's one console recipe, there's multiple recipes are there around like in our org, it's like 80, 90 recipes. So those are application recipes. They set up an application. But the point is that console agent is a library. You want to set up the console agent and tell it that I want to register my services as a library. So I'll give an example as well. What you need to do in this such case is that you need to use your console client recipe in a singular manner and use it in every, create abstractions and use it in every VM like so. Just add it into a run list, add node attributes, and you're done. You don't need to implement the console client separately in all the application processes, which is a very bad idea. So just talking about like deriving and expressing your configuration as data, you can create node attributes and define that I want these services with these health checks for multiple services. Let's say a Patroni service. I want to create a read or a write service. I can just give a script that this is my health check. If I am a leader, I point the leader DNS to me. If I am a replica, point the right DNS to me, point the read DNS to me, my bad. So there can be multiple ways in which these can be expressed for multiple VMs. Like Elasticsearch would have a different health check, different port, and similarly, Postgres, Redis would have different things. So that you need to create abstractions so that these multiple processes are avoided and you can just use one client recipe. Just more information on how it is being done. It's just one recipe which uses the service definitions. And here also I talk about how it's a bad idea to just follow everything I just said. So the point is that it is meant in a normal scenario that you need to just pass single string values in configurations, which is being defined by the Ruby actual chef guide. But here I disagree because it's much more readable, it's much more extendable to just pass hashes. And it's possible to maintain it via actual Ruby code as well. So I disagree with the actual Ruby chef guide here, but yeah, more extensible and better in abstractions to go. Just talking a bit more about writing extendable abstractions. You can, if you go ahead and define this remote file, I want this remote file to be downloaded at this path. This will work only on Unix-based systems, because this path is not will not work in Windows systems because Windows have forward slashes, right? Something like this, if you just use the Ruby method, this would be much better because this works on multiple systems. Similar to this, there are multiple libraries which configure systemd. If I go ahead and configure systemd manually, what would happen is that my processes would not work in other distros, right? It won't work in Next, it won't work in other distros. So that's not a good idea. You need to have multiple things there. I mean, this is a very weird thing. I have been on both the sites. I have created huge stuff in the infra which caused other people to curse me, and I have been here as well. So if you do not follow much standards, if you do not take approvals, you do not write testable code with integration tests, following better abstractions, following the principles, you might be on this. And just talking, how much time do we have? 5 minutes? Okay. Just talking about how deployment works in such systems is that earlier what we used to do is that we took the IPs. We have a deployment system. We took the IPs from Chef that what are the nodes which have these IPs, and we would fetch the IPs manually and perform deployments on those IPs, which is a very bad idea. So there's one more better way to do it is that use service discovery in your systems. Use console, just use a console agent, use console DNS, perform service discovery via that, and just deploy via that. So it's a much better idea. And apart from that, just one small thing apart from here is that you need to make sure the same way your application is being released via semantic release or whatever principle you follow, you need to make sure that all the principles are followed in Chef cookbooks or any configuration languages, any configuration playbooks you follow. It needs to have proper change logs, automated release notes and everything, so that people, because it's a product at the end, right? People don't really treat it as a product because developers are using it, don't really care about developers, right? So that the point is that you need to make sure that it is being used. the way it's supposed to be. Okay, let's go forward. Yeah, a bit more about Chef, because the actual people are questioning that Chef is dead. No one is actually talking about it, and there's a lot of I agree with it as well. But my talk and my topic was surrounded around a lot of configuration management, because Chef in general, I just took it Chef as an example, but you can apply these principles to configuration management in Ansible, in Puppet, in multiple day frameworks. So that is there, and there are multiple mature continuous orchestration toolkits, Istio. Everyone is doing a great job there, but the point is that you would need VMs at the end. You can go ahead and you can just run Postgres on a Kubernetes cluster, which is not really a good idea. You can use it, but that doesn't make sense. Uh, but the point is that it's easier for application developers now, because a lot of people, we have seen a lot of cases where people moved to Kubernetes, didn't understand it, moved back to VMs. So a lot of people have done it, but the point is that VMs are here to stay, at least for 5-10 years, I guess. I'm not sure what's going to happen, who comes up with a new Kubernetes or something with a new container orchestration tooling, which would change the scene, but no one knows. And the point is that Chef has a weird business strategy. They just came in and pulled a Terraform. Terraform pulled the Chef as well. So what they did is that they have a business source license and stuff like that. They say that they're open source, but they're not actually open source. So that is a weird thing. And we're just running the older Chef versions to avoid that. So yeah, and a lot of new companies are not choosing Chef because of this weird business license and everything. And there are better alternatives. But again, my point is that the configuration management is configuration management, so it should be the same. Okay. Okay, I cannot move it. Yeah, that's all. I think that's most of it I wanted to talk about. All the links and the deck, everything is on this, so you can check it out. Yep.
Check. Hi, you mentioned about VMs and Kubernetes. You're one of the few people I heard who say the VM is a better approach than Kubernetes. So I also believe kind of similar. So want to know your reasons of why you feel so. And because obviously Kubernetes is the new thing and everybody wants to move to that. And it's a point and click kind of approach where you can do a lot more. So want to know your views of why you feel that way.
My perspective comes more around like what I mean. I have in a developer productivity team, so that it's around what developer actually wants. So a lot of developer we have seen, developers want VMs because it's just easier for them to manage it. And as we move from a application owner based model to a managed model, which we manage everything on our own, it's easier for us to manage. That's one thing. Apart from that, is there are a lot of downsides as well. I won't really suggest VMs for all application workloads, like just running a stateless Rails server doesn't make sense to run VMs. You can use Kubernetes if you require to, because it's easier to manage in that sense. But running stateful VMs, I won't really suggest actual running on Kubernetes, because it brings in more complexity and it's difficult for the application user to handle stuff there. I mean, you can use it with volumes. It's possible, but the point is that mindset hasn't changed in a while, and it will take still some time to change it. A lot of new startups are doing good stuff in the container space as well. But my answer remains the same: is that VMs are much easier, and it's much the control is much more. You can do more things on it. Yeah.
Have you for VM states? Have you tried Nix? Like, because it allows you to set up that box in the, like if you have just one configuration file, the whole box will be up with that same configuration. So
yeah, we have done a spike out of Nix, and it's much easier to do stuff there. I agree with that, and it's much more easier to manage it as well. But the point again is that we have done it in a spike way, that we just did a test and small test. We have like around 2,000 VMs running, and you know it that we have multiple things running there. And then the point is then upgrading it from a Ubuntu system to a Nix system is very difficult at this point, because there are a lot of things which change when you switch to distros, right? So it's nice, it's fun, but doing it on a very large scale, is it worth it or not? That remains a very big question. Yeah.
All right. Thanks a lot, Abhijit. And I think with this, we are done with the talks for the day. And right now, I think the floor is open for having conversations with new people. Before we leave, I think we would like to give a shout out to Gojek for allowing us to kind of host the event here. And
thanks folks for coming, and looking forward for the December meetup as well. Encourage more people to come, your colleagues and everyone. Of course, we are looking for speakers. So whatever you have the ideas for to speak, please reach out to us on the meetup group, and all the slides and the recordings would be shared there. And yeah, we have snacks now. We have some snacks for you, and yeah, good to see you again, and looking forward to the next meetup. Yeah, thank you.